Hello and welcome to In Simple Terms with Satish. Picture a small drone hovering above a field. From the ground, it looks still. Technically, it is fighting gravity, wind, motor torque, vibration, and battery voltage every second. A gust tilts it, a gyro senses the rotation, and the flight controller changes motor speeds before your eye notices the wobble. This week, the FAA said more than 700 unauthorized drones were seized during FIFA World Cup 2026 security operations. That safety story gives us a useful engineering question. How does a small machine with 4 spinning propellers actually fly, turn, hover, and not immediately flip over? Start with lift. A drone propeller is a rotating wing. As it spins, it pushes air downward. The air pushes back upward on the drone. That upward force is thrust. If total thrust is greater than the drone's weight, it rises. If thrust equals weight, it hovers. If thrust is lower, it descends. So a drone is not floating. It is throwing air down fast enough to hold itself up. To move sideways, it tilts. If the rear motors push a little harder than the front motors, the drone tilts forward. Once it tilts, some thrust still points upward, but some now points forward. The drone moves by leaning its lift in the direction it wants to go. Turning is different. If all 4 propellers spun the same way, the drone body would twist in the opposite direction. So most quadcopters use pairs of propellers spinning clockwise and pairs spinning counterclockwise. Those opposite rotations cancel unwanted spin during normal flight. To yaw or rotate left and right, the flight controller slightly speeds up one diagonal pair and slows down the other. That creates a controlled twisting force without changing total lift too much. This is why the key object inside a drone is not the camera or the remote. It is the flight controller. When you move a joystick, you're asking for direction, speed, height, or rotation. The flight controller converts that request into motor speed changes. To do that, it needs sensors. The most important sensor package is the IMU, the inertial measurement unit. It includes gyroscopes that sense rotation and accelerometers that sense acceleration. Many drones also use a barometer for altitude, GPS for outdoor position, a compass for heading, and downward cameras or optical flow sensors near the ground. The drone compares two things constantly: where it is and where it should be. If it tilts too far forward, the controller corrects motor speeds. If a gust of wind pushes it sideways, the controller reacts. If the battery voltage drops, the same motor command may produce less thrust. So the system has to compensate or warn the pilot. This is closed loop control. Measure what actually happened, compare it with the target, and correct the next command. In real drone stacks, the fast stabilization loop can run hundreds of times per second. At 400 Hz, each correction window is about 2.5 milliseconds. The exact number depends on hardware and software, but the point is simple. Stability is not human reflex. It is real-time feedback. That is also why drones have limits. Extra payload means more weight. Wind means more correction. Damaged propellers create vibration. Weak GPS can hurt position hold. And a low battery changes the power available for control. This is why aviation rules matter. The FAA treats drones as aircraft in the National Airspace System. In the US, many recreational flights must stay within visual line of sight and at or below 400 feet in uncontrolled airspace. And registered drones generally need remote ID. Once small aircraft become cheap and easy to fly, the larger system needs identity and safety boundaries. In simple terms, a drone flies by pushing air down. It moves by tilting that push. It turns by balancing opposite spinning propellers. And it stays stable because a flight controller uses sensors and feedback loops to make thousands of tiny corrections. The mental model is this: a drone is not 4 propellers attached to a camera. It is a flying, balancing robot. The propellers create force, but the control system creates trust. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish and share this episode with one friend who likes technology. I will see you in the next episode.